G'day viewers, well, doing a bit of a clean up today and I came across these. I forgot I had these. These are old Ever-Ready batteries made by Union Carbide in Australia. When Australia actually made batteries, mercury free, so they're not old enough to contain any mercury or cadmium. I find my voltmeter, I'll see if they're still holding any voltage. 9 volt on the AA battery there. Do a voltage test on them, see if they're holding anything. Not the best of lighting, or yeah, I haven't got much light around here because it's late in the afternoon and I haven't got much time these days to make videos. This, and I'll put the polarity the right way first. This 9 volt still got 7.4 volts left in it. It's kind of puffed up at the top too, so this is sitting in an old I can't remember now. It was a really old, like an automotive diagnostic tool from school years ago. It had this battery sitting in it when the tool was made, probably in the 70s. Okay, let's say milliamps. It won't be much. .6 milliamps, 7.4 volts left in it. That's pretty good for being sitting for so long. This is a painted metal, so it's not paper. This is a paper type. I'm trying to get the camera to focus here somewhere. Made in Australia by Union Carbide. Now I'll test the voltage of this one, see what this battery is holding. I won't be popping these batteries. These are just very vintage. 0.01 milliamp. This battery is very dead. Volts. Oops, stay there, stay still, damn battery. .5 volts. Still holding its full charge voltage, but no amps. Now this battery was sitting on the floor of my neighbour's garage. They got an old I think it's a Dodge Ute from 1969 with a slant 6 in it, and it's been sitting there without its cylinder head as a project for a long time, and they just had junk stored in the back of it, and this was just sitting on the floor underneath that vehicle. Just remarkably good condition for sitting on the ground. So you don't see Aussie made batteries these days, especially these types. And also I got some little speakers here that are going to get popped. We'll wire these up across the MOT and see what happens. I'm going to wire the MOT up through the meter, see how much amps or kilowatt hours we're using with the meter. Made some improvements, a bit more safer, no exposed wiring, so I haven't got any cord extension sockets, so I have to just go by these for the time being. So I'll get this all set up and we'll start modding things again. Okay viewers, just hooked up. That's just the IPF driving light switch, high beam, low beam, with some LEDs on it. Let's see what that does. Heavy smoke. Interesting, the switch burns out, can't handle the voltage. And it smells. And the meter's not really spinning as fast as I thought it would. Alright. Safety first. That hangs up nicely. A very strong hook. Very sturdily hung up. It's nice and level. Alright, let's see what else I can burn. It don't click no more. LEDs didn't even pop. Yeah, melted the switch internals. Switch, haven't burnt that out, that's good. Try and hook these up. Didn't know where the terminals I grab onto, so might be a bit difficult at first. Hang on, get this off camera for a second. Okay viewers, little 0.25 watt speaker. I think it's 8 ohms. 3, 2, 1. Bit of hum and that's about it. It certainly is handling the current. Yeah, not drawing much current now. Safety first. Now, I was expecting it to just go poof, voice call to shoot out in flames, but let's see what that looks like close up. Whoops. Yeah, it just pushed out. Didn't even get very hot. It ran open circuit, but it didn't draw an arc in the process. That's kind of disappointing. This one is got a bigger than usual magnet on it. This is an older speaker, so this could be stronger. Oh, I'll do the same process again. I'll hook it up. Cross here like that. Just clamp it on like so. As long as it's touching, it doesn't really matter. Just like that. Oh, that's what this does. Hopefully this is going to give me some flames. Oh, bloody trial drift PowerPoint. 3, 2, 1. Whoa, that's a tough little speaker. Still humming. Whoa, that's a very tough little speaker to handle all that power. Look at that. Look at the meter. This is actually more energy efficient than I thought doing this destruction. Alright, speaker's not burning out. Safety first. Oh, good light. Careful not let these touch either, because this is only probably 12 volt max rated cord, and if they're resting on each other and the voltage happens to break through, it's going to burn the insulation off these straight away. So yeah, these are only just a crappy Dick Smith jumper lead kit. Yeah, it got warm but not hot. Did not go open circuit. That's interesting. That can handle the power of a MOT. That's quite a good quality little speaker. So that still works. This is one of these little headphone speakers that sound actually half decent for the price you pay for them. So I'm going to hook this in here up. This one's going to be a bit more of a challenge to hook up, so let's see. Okay viewers, I've hooked it up. I'm going to plug this in. Lots of smoke. Yeah, that can even handle the power of the MOT. That's probably a 0.25 watt, designed for 1 or 2 volts max on a amplifier output of an iPod, and I'm putting 2,400 volts through it. But the current's not high enough, so that's why it's lasting so long. So this is done almost on the zero, so it's 99,017. So 99,017 kilowatt hours. Actually found out too, it's made in 1976, and Q is state, so it's Queensland. So this is a date you go by, not this N numbers. So 76 is a year it was made, so 1976, and Q for Queensland. Look at that, nice light. The speaker's still handling it. Safety first. Nice warmer. Yeah, it's not even warm yet. So if there was more current coming out of this thing, these speakers would have went up in flames by now. Didn't get very warm, so they'll still work. These are the crappier, this is a crappier one of the two. This is a 16 ohm speaker, 0.1 watt. Got some more things to pop. Okay viewers, I got the little comparison here. One of these CRTs I heated up the neck with a blowtorch when it was cold and cracked around the neck evenly, and that was it, made it easier for me to just withdraw the gun assembly without damaging it at all. This is a Samsung one from a Samsung CRT, and there's little green things which is glass. They use that to secure the assembly in the factory. You look dead on. That little thing at the very back has got a tiny pinhole in it. That's where the electrons come out. And this little halo ring here is a getter. Picks up water crap inside the CRT and it's attracted to that little ring. On the other hand, this one's a Panasonic one from a Panasonic CRT that was made in Japan. And you can see it's a slightly better quality assembly. It's only got one little thing holding the getter on. The Samsung has two little bits of metal. This only has one. Other CRTs, a getter will just hang down and flop down on a little plate. A normal, like big normal TV CRTs. These little tiny rear projection ones are just on the end of here. And the gun's sitting right at the back there, a bit hard to see. The gun itself's this little bit at the back. Now if I can find which two go to the filament, you see the filament, it's a bit hard to see on camera. Looks kind of like the filament of a valve. It's got the white and it's got like the bit that goes inside it, the white protecting on the outside of it. I've already blown that one now up, but this one I'm going to wire it up across that MOT and watch it melt down. It's got to find which two pins are it. So I work out the pin combination and I'll wire this up across the MOT and watch it just arc out. Because they're only meant for, I think they're probably about 6 volts, so probably 20 or 30 milliamps max, normal operation. Let's see what I do at 700 milliamps, 2400 volts. Okay, viewers, it's a bit hard to see because it's getting dark, but I've figured out the pin combinations. It's hooked up. I'm going to plug it in. Hopefully there's no shorting. Whoa! Obliterated that thing. Okay, it's gone open circuit. Meter's not going very fast. Always unplug that before you do anything, so don't kill yourself. Oh, it looks like I melted some glass there in the process. Alright, just give it a little jiggle and see what happens. Interesting. That filament's toast. Bit hard to see, but it is spinning. It's a more fun way to destroy a CRT. Now if I could find a CRT that I haven't taken apart, I'll be able to do this while the CRT is still under vacuum. Although once the glass heats up and melts, it's probably going to implode. So it might be a bit dangerous. Glass is red hot. Melted the glass and the insulation on my jumper lead. So I'll switch off. There you go, dead short. Good indication. Oh, it's wrecked my jumper lead. Destroyed it. Yeah. Only cheap, nasty Dick Smith, so it doesn't matter, I haven't lost much. Yeah, we get some light. Yeah, just get some remaining sunlight on here. We'll be able to see what happened. Yeah, the glass has gone red hot. It's melted the glass. The filament is non-existent. Yeah, the glass is gone. There you go, viewers. Overpowered electron gun. So yeah, thanks for watching.